Hello and welcome back to Agora Math Circle's Mathcounts training. Now, this is session 5 of a 12-part series in which we'll be teaching you everything you need to know about math counts. So if you haven't watched the previous videos, go ahead, watch those, and when you're done with that, come back to this video. So without further ado, let's get right into it. And by the way, my name is Mugil Shanmugam, and I'm going to be presenting these videos. Okay, so what exactly are we learning in today's session? So today we'll be covering the following broad problem topics. So these are just basically types of problems you're going to see in your math counts exam, and you need to be able to be comfortable in solving these problems. So we'll be covering balls and boxes, clock problems, page numbers, and maximum with inequality. And so underneath these problem types, we will have some subtopics. So underneath the balls and boxes, we'll have basic knowledge and sound problems. Underneath clock problems, we'll have the basic concept and formula, as well as sound problems. Underneath page numbers, we'll have to learn arranging digits in numbers and sample problems. And finally, along with our maximum with inequality, we'll need to learn some formulas and sample problems. So again, these are just some broad problem types you need to be able to solve quickly and effectively, so we have many formulas, tips, and techniques you can use to solve these. So let's get right into it. So our first topic for the day is called balls and boxes. And basically, the first thing we need to go over when we're talking about balls and boxes problems is we need to go over the fundamental counting principle. Okay, so we've covered this in previous sessions, I'm sure, and I think we also have like a dedicated topic just to this one. I'm just going to go over it real quick here. So if a task consists of k parts, and the first task can be done in n1 ways, the second task can be done in n2 ways, and so on, the total number of possible results can be found using this formula. n1 times n2 times n3 and times n4 and 5 and 6 and 7 until you get to nk. And remember, k is the number of parts you have total. So again, what you're going to do is you're going to find how many ways you can do each part, and then you're going to multiply that together to get the total number of ways. So that's just a quick and easy formula you'll probably need to know. Now, our next one is called permutations. And a permutation is similar to a combination. So we've learned combinations in previous topics. I think we covered it once or twice. But we also use permutations, which are similar to combinations, but we use them in situations when order matters. So these are the key words, order matters. So what do I mean by order matters? So there's a good example that I can usually give, and it's like, let's say that they ask you to choose some 3 contestants out of 10 and see who gets first, second, and third place. So basically, in this situation, order matters because it matters who gets first, who gets second, and who gets third. It's not the same if you give one guy first or if you give him third. They're 2 different scenarios, so 2 different ways, you could say. So because of that, this problem would require a permutation because order matters. It matters who gets first and who gets second. It's not like first and second are equal. So this is a situation in which order matters, so we'd use permutations. Now, when we have different elements with no repetition, and we're choosing m elements from n total elements, and order matters of course, then this is our formula. So when they go p n of n and m, this means permutation of n and m, which is n factorial over n minus m factorial. And again, when it's a factorial, you're simply multiplying it by every single number that's smaller than it. So 4 factorial will be 4 times 3 times 2 times 1. So that's pretty self-explanatory, but the main thing we need to know here is when we have different elements, so each element is different, with no repetition, so you don't have any 2 similar elements, and we're choosing m elements from this n batch of total elements, this is our formula. N factorial over n minus m factorial. Okay, so let's go a little more into permutations. So in the same scenario, but when we have repetition allowed. So you could have 2 of like the same people, or maybe 2 of like the same crayon, same color crayon. I'm just going off the top of my head here, but those are just like 2 basic examples where repetition is allowed. So our formula then becomes n to the power m. It's simple as that. So before we were using factorials because of an actual permutation, but now since repetition is allowed, our formula is simply n to the power m. Similarly, if we take m elements from n different elements and we arrange them to form a circle. So we're doing this exact same situation here, but we're making them into a circle, and then we want to find the number of total ways. So our formula is going to be p of n and m. So again, p of n and m is n factorial over n minus m factorial. So that's our formula right there. So that is going to be divided by m. And that's how we get the total number of ways you can arrange these elements in a circular shape. And now when you're talking about like the total number of ways for n total elements to be chosen, right? You want n elements out of n total elements, it's going to be n minus 1 factorial. So again, those are some simple formulas that we're going to use when we're using permutations. Okay, so now we're actually going to get to balls and boxes, the entire point of this topic. So the number of ways to put m distinct balls. So distinct balls, they're all different balls. And we want to put them into n labeled boxes. So the number of ways is n to the power m. You may recognize this formula. It's because it's the same formula as this, because repetition is allowed. So again, if we have m balls and we want to put them in n boxes, this is our formula, n to the power m. Now, the number of ways to put n identical balls in m labeled boxes. So these balls are all the same. So then what we can do is a combination. So n plus m minus 1, choose n. Or n plus m minus 1, choose m minus 1. So again, if you're a little confused about this combination notation, don't worry, we're going to go over it in a few slides. But just so you know, these are just the simple formulas that you can use if you want to find these balls and boxes problems. So if they say you have 7 balls in 10 boxes, then you can use this formula to find the number of ways you can put these balls into the boxes. So again, here the main thing is you need to be able to keep separate which one is which. You need to be able to differentiate between the different situations and which situations you use different formulas. So if you need a minute to go back and rewind all the formulas, go ahead and do that. Okay, so now we need to talk about permutations for indistinct elements. So what do I mean by indistinct elements? Well, what I'm talking about is elements that are similar or the same basically. So if I have 2 yellow crayons, they're the same, right? So that's an indistinct element. So imagine you have n total elements. So I have 10 elements, that can be my n, with sets of identical elements. So let's say I have 2 soccer balls, they're identical, and 2 basketballs, they're identical. So my soccer balls would be my R1 group, my R2 group would be basketballs, and let's say my R3 group would be baseballs or something like that. So the total number of ways to permute or arrange these different n elements is going to be n factorial over R1 factorial, R2 factorial, RK factorial. So going back to our previous example, right? So R1 is our group of soccer balls, and we have 2 soccer balls. So it's going to be 2 factorial down here in the denominator. Similarly, we have 2 basketballs, so it's going to be 2 factorial. We're going to keep doing that until we get to RK, which is the total number of groups we have. And n factorial is simply going to be the total number of balls we have. So we have 10 balls here, so 10 factorial over 2 factorial times 2 factorial. This is just like a very simple formula and situation I've given, but it will get more complicated when you use more terms, more identical elements, and more sets. But this is just the basic formula that you would use when you're given situations where you have similar elements grouped out of a total set of elements. Okay, so this is a quick review of combinations. I think this is like the 3rd video I've put this slide in, but this is a really important topic. That's why I keep stressing it over and over again, because you need to know this topic. As you've seen, I'd bet like half of the problems on Mathcounts probably use some variation of the combination formula for like the different types of problems. And even if half of the problems don't use it, you still need to know it, because you want to be able to get those problems that do use this as part of their formula or as part of the main problem premise or whatever. You just need to be able to apply this formula successfully whatever comes. So when you see x is equal to 10 choose 2, so you read this as 10 choose 2, and we use this formula, right? So it's n factorial over r factorial into n minus r factorial. And we went over what factorials are. So out here I just calculated this one, right? So combination of 10 and 2, so 10 choose 2, is 10 factorial over 2 factorial into 10 minus 2 factorial, which is 10 factorial over 2 factorial times 8 factorial, which is 45. So again, combinations are simple. But now what we need to really think about is how are these different from the permutations we learned earlier? Well, in permutations, order matters. So it matters who gets first place, who gets second place, and who gets third place. But in combinations, order doesn't matter at all. So that's just what we need to know. So when order matters, if they're asking you to place people in a race, or like they're asking give different awards, and like they want first, second place, a third place, a fourth place, then you should use a permutation because order matters. But combinations are used when order just doesn't matter. It's just random. You're just finding the ways that you can arrange something. Okay, so here's our sample problem. how many permutations of the letters in the word tattletale are there? So what you need to know real quick is a hint. You need to know that there are similar elements here. You have 4 identical T's, 2 identical A's, and so on. So make sure to use the appropriate formula based on this. Okay, so go ahead, pause the video here, work this out on paper, and start the video again when you're ready to see the answer. Okay, so hopefully you tried it out and you got your answer, so let's go into how you can solve this one. So there are 10 letters in total. 4 T's, 2 A's, 2 L's, and 2 E's, right? In the word tattletale. So T's are all similar. They're like identical elements. So that means we need to use that formula that we had for identical elements right here. N factorial over R1 factorial times R2 factorial until RK factorial. Okay, so I'm going to come back here. Okay, so what does it tell me? It tells me that we have 10 letters in total, and I have 4 T's, so that's my R1, 2 A's, my R2, 2 L's, that's my R3, and 2 E's is my R4. So when I put this into my formula, I'm going to get 10 factorial over 4 factorial to 2 factorial into 2 factorial into 2 factorial. So when you calculate that all out, that's a lot of multiplying. But when you do that, you're going to get 18,900. So there are 18,900 ways to achieve our task. And so that is the basis of what we've done. And we've basically solved this using our formula. And the main distinction you really need to make here was you need to realize that there were identical elements. So you had to use that formula. Okay, so let's move on to our next topic for the day. Clock problems. So this is just some really basic knowledge that you probably already know, or you've probably even if you don't know it, you probably have the basics of this. You just are going to need to know this for any problems that say, what is the degree between the hands at this time? You've probably encountered those problems before, but it's just some basic knowledge you need to know. So the minute hand moves for 5 minutes to cover 30 degrees. And the hour hand moves for 60 minutes to cover 30 degrees, right? So minute hand's pointing at the minutes, hour hand's pointing at the hours. So the minute hand moves 6 degrees per minute, and the hour hand moves 0.5 degrees per minute, so 1/2 degrees per minute. Using this, we can create a couple of quick and easy formulas that we use to just solve out our problems, right? Okay, so let's go and try to solve this. So using our original equations, the angle covered by the hour hand in m minutes is going to be 0.5 m, and the angle covered by the minute hand in m minutes is going to be 6 times m. How do we know this? Well, we know that this is the rate that the hour hand moves at, and this is the rate that the minute hand moves at. So all we have to do is multiply it by the number of minutes to find how many degrees it's moved. And the difference between the speed of the minute hand and the hour hand, well, we're going to just subtract our speeds. So the first one was 6 degrees per minute, and the second one was 0.5 degrees per minute. So when we subtract that, we get 11 over 2 degrees per minute. So yeah, those are some quick and easy formulas you can use when you're trying to solve these quick problems. Okay, so go ahead, you can pause it here if you want to quickly rewind these formulas, but after this I'm going to go on. Okay, so let me keep moving. Here's a sample problem. So again, clock problems aren't too big of a deal. They're just simple formulas that you need to know so you can quickly calculate any of these problems asking for the angle between the two hands at a specific time. Okay, so calculate the angle formed between two hands when the time shows 4:30 p.m. Okay, so this one, it should be fairly simple if you use the formulas. And I know some people don't like using formulas, so if that's not really your thing, you could also draw this out on a piece of paper if you're really good drawing, or diagrams are just your forte. And then you can use that to figure out the angles. So go ahead and do whatever you think is best for this problem. Pause the video and solve it, and rewind the video, or start the video up again, sorry, when you're ready to start again. Okay, so let's start. In this situation, the minute hand is at 6, right? Because it's at 4:30, so it has to be 6. And the hour hand is at 4. So I know some of you guys are going to be like, well, the hour hand is not at 4, it's in the middle of 4 and 5, it's at 4:30, right? Well, we will account for that, but first we're just going to try to solve it when the hour hand is flat at 4, because it's easier to do that way. So if we draw this out, we discover that the angle is 60 degrees between them. You should be able to recognize that just by drawing it. However, since the hour hand is between 4 and 5 at 4:30, so now we're accounting for that slight adjustment, we need to find that it has moved 1/2 degrees. Remember, so the hour hand moves 1/2 degrees per minute, and it's been 30 minutes, right? From 4 to 4:30. So it's moved 15 degrees in that time. So originally it was 60 degrees, but then it moved 15 degrees. So 60 minus 15 degrees is 45 degrees. Pretty simple. Now, if this problem was harder for you to solve using a diagram, you could simply apply the formula to see how far both the hands have come from 12. So if your hand is at 12 and you know how many minutes it's been moving for, right? So simply multiply that by the speed. So 6 degrees in the case of the minute hand, 0.5 in the case of the hour hand. You can multiply and you can find the different amount of degrees that they've both moved. And then if you subtract and you find the difference in between the two, then you know that the angle between them is that difference. Because one of them is here and one of them is here if you really think about it, like more like here. So if you find the amount of degrees both of them have moved from 12, you can find the difference in between them, and that's the angle they form together. Okay, so again, that one, you have two ways to do it. Use a formula if you want, or you could draw it out. Okay, so let's move on to our third topic of the day, page numbers. Okay, so to solve these problems, we need to know how much digits are used to name page numbers. So what they'll do in general is they're just going to give you like, I don't know, they use 10,000 page digits, right? So they're not going to say how many page numbers there are. They're just going to say this many digits were used to number this many page numbers. And they're going to be like, find how many pages the book has. So to solve these problems, we need to know how much digits are used by how many page numbers. So the pages 1 to 9, right? So the page numbers 1 to 9 use 9 times 1, 9 digits. So each of these numbers has only a digit in them, and there are 9 of these numbers. So 9 times 1 is 9 digits. So the first 9 pages are going to use 9 digits. So the pages 10 to 99 are going to use 90 times 2, which is 180 digits. So there's 90 numbers, each of them has 2 digits, so there's 180 digits used by these pages. The pages 100 to 999 use 900 times 3 digits, which is 2,700 digits. And finally, the pages 1,000 through 9,999 use 9,000 times 4, which is 36k digits, so 36,000 digits. Okay, so real quick, what I've essentially done here is I've taken out each page number and I found how many digits are used in each set. So this is pretty easy to figure out. You don't have to memorize all these numbers. You could always just figure it out right there on the exam, right? Because you know how many numbers are in between 199, and you also know that they're all 3-digit numbers. So the number of numbers in between 199 times 3 will give you the total number of digits used by those page numbers. So this one, you should be able to solve it wherever and like wherever. So then based on that, you should be able to figure out how many pages there are in a book. And so also we need to go over the appearing frequency of each digit. So the units digit appears 1 out of 10 times. The tens digit appears 10 out of 100 times. The hundreds digit appears 100 out of 1,000 times. And the thousands digit appears 1,000 out of 10,000 times. And here I have a quick little table that you should be able to like use. You don't have to memorize the whole thing, obviously, but be able to just utilize it if needed, right? So how many times does the digit 0 appear in numbers 0 to 99? It appears 10 times. So based on that, you kind of just go ahead and use it. So from numbers 900 to 999, the digit 0 appears 20 times. So based on that, if they do ever ask you a problem like saying what digit is most frequent to appear between these two numbers or something like that, you should be able to just kind of think of the table and go ahead and try to solve this. Obviously, you don't have to memorize the table, just be able to kind of recognize overarching patterns here. So a pattern you could spot here is from 100 to 999, 0 seems to be appearing 20 times in each of those sets. Each of the sets of 100 numbers or 99 numbers, you're seeing 0 appear about 20 times. So based on that, you should be able to calculate some percentages, and you can spot these overarching patterns that you should be able to utilize pretty effectively whenever you get a problem. Okay, so here's our sample problem for page numbers. And as I've said, they're going to give you a bunch of digits and they're going to ask how many pages there are. It takes 7,641 digits to number the pages of a book consecutively. How many pages are there in this book? Okay, again, so there's 7,641 digits to number the pages of a book consecutively. How many pages are there in this book? Okay, so again, This one should be pretty simple. You simply need to calculate how many sets of numbers there are, or how many digits each set of numbers uses. Like, so the pages 1 to 9, how many digits do they use? And if you subtract all that out, you should be able to figure this one out with a little ease. So pause the video here and solve this problem out. Okay guys, so hopefully you solved it out real quick and you got your answer. So let's go into how you can solve this one. Okay, so your first 999 pages use a total of 9 numbers plus 180 plus 2700, which is 2889 digits, right? So the first 999 pages use 2889 digits. So how exactly did we calculate this? Well, basically we went back here, right? And you could have done this on your paper too. Just 9 times 1, 90 times 2, 900 times 3. Right? And then we simply calculated the number of numbers in our set. So from 100 to 999, there's 900 numbers. And each of those numbers is a 3-digit number. So times 3, and we got how many digits there are. So based on that, we're just going to add up those. So we know that the first 999 pages are going to use 2889 digits. So this means all the remaining pages have to be 4-digit numbers, right? Because we already used all 3-digit numbers. And we have 4,752 digits remaining, because this is the total number of digits we had, and we already utilized these for the first 999 pages. So we have 4,752 digits remaining. Okay, so now that we have this many digits remaining, we know that all the rest are numbered by 4-digit numbers. So we can just divide by 4. And when we divide this by 4, we get 1,188 more page numbers. So many people will just stop here and say, okay, so there's 1,188 page numbers in this book. But that's wrong, because you need to add up these digits that you found in the beginning. Remember, so this is for all the remaining pages, but the first 999 pages use this many digits. So you need to add that in to your total. So when we add those up, we're going to get 2,187 page numbers. So again, so we have our digits. This is how many digits are used. However, they're asking how many page numbers there are, and we know that's just 999 pages. So when we add that up, 1,188 plus 999, well, we're going to get 2,187 page numbers. So this many digits, 7,641 digits, are good for 2,187 page numbers. So again, that was a lot to say, but when you do the math, this should be pretty simple. You're just doing some division to find how many page numbers are left, and then based on that, you should be able to calculate, when you add that up with the page numbers that you had in the beginning, you should be able to find a total number of page numbers that are numbered by that many digits. Okay, so let's move on to our last topic of the day, maximum with inequality. Okay, so when I say maximum with inequality, it's basically like they'll give you a set number of variables and they're going to be asking you what is the maximum total that this could equate to. So an example would be like, they'll be like a squared plus b squared plus c squared is equal to 299. What is the maximum total that a plus b plus c can be? So for these, we'll have to use many different inequalities because we can't predict what type of problem they'll give exactly. They're just going to be asking you to find the maximum, but it's not necessarily going to follow a set pattern. So you want to be familiar with all these inequalities so you can use them based on what the situation is. Okay, so first we have our trivial inequalities. And these ones are pretty simple. A squared is greater than 0, and a squared plus b squared is greater than 2ab. And this is holding true when these two are positive real numbers, right? So a squared is greater than 0, and a squared plus b squared is greater than 2ab. So again, a squared here, a squared plus b squared here, there's different variables that you're plugging in. And so based on that, you should be able to calculate what the maximum value is for them. Okay, and now we also have the AM-GM inequality. So this is when A is equal to B, which is equal to C. And A and B are both positive, and the other condition is A times B, or A plus B is constant, so it's a constant number. And the maximum or minimum value is achieved when A is equal to B. So this is for when A is equal to B is equal to C. They're kind of all the same number, right? And for this, we can use this different inequality. So A plus B over 2 is greater than or equal to the root of AB. So here, A and B are just like two basic values that you're using here, two variables. And so you should be able to use inequality by plugging in any value that they do decide to give you. Now here, we're expanding it so it works for C too, because this one works for A and B, but it doesn't work for C. So we need to make like a new inequality that we can use for C. And this is a pattern you'll see throughout the course where we're basically having a basic inequality or like a basic problem equation, and we're going to expand it to include more variables, more terms, but you will see the pattern in between them. So here it was a plus b over 2, right? Because we're dividing by 2 variables. But here it's a plus b plus c, so that's 3 variables, so we're going to divide by 3, and that's going to be greater than or equal to the cube root of a, b, and c. Here we're taking the square root because there's 2 variables. Here we're going to have 3 variables, so we're taking the cube root of this whole thing. Okay, and then here's our final one. A cubed plus b cubed plus c cubed over 3 is greater than a times b times c. So this is kind of similar to this one, except they'd made it into like a cube root, not a cube root, sorry, they cubed all the numbers, so that's why we need to change it accordingly. But again, so these two are applicable when you have a, b, and c, 3 of them, and this one is applicable when you have just a and b. And again, make sure you're meeting the conditions, because you don't want to use one of these inequalities and find that it's wrong because you didn't meet the conditions. So this is for when a is equal to b and it's equal to c, and a and b are both positive, a times b or a plus b is a constant, and the maximum or minimum value is achieved when a is equal to b. So make sure these conditions are met when you're using the AM-GM inequality. Okay, so here's Cauchy's inequality. So here I will go over this bottom formula, but first I just want to quickly go over the top because I know that this may seem scary. So here we have sigma notation, and this is the summation symbol, right? So here's a summation symbol, AI, BI squared is less than or equal to the summation of AI squared into summation of BI squared. So what does summation mean? Summation means you're just going to add all the different terms you have here. So when they say a to the I, they're basically talking about all your different a terms. So here this could be a squared, not a squared, a subscript 2, a subscript 3, and each of these is a different term. So what you're going to do here is I'm going to multiply my a term times my b term, and then what I'm going to do is I'm going to add it with all the other a terms and b terms. So what this means is, let's just say my a2 is 2, and my a3 is 3. So what I would do is first I'd find what this is when it's a2 and b2. So let's just say that's 4. And then I'll find the same thing when it's a3 and b3. So a subscript 3, b subscript 3. Let's say that's 6. So because I have this summation symbol, what I'm going to do is I'm going to add 4 and 6. That's 10. Then I'm going to square 10 to get 100. And that's my answer. So don't be scared of this summation symbol. It basically means add up all the terms you have. What you're going to do is you're going to solve this for each of these variables. So like when, let's just say a1 is 3, a2 can be 4, a3 can be 6. I don't know, I'm just giving off random terms. But what you're going to do is you're going to like kind of solve this for all the different values of a. So a1, a2, a3, a4, so on. You're going to solve it for all of these. You're going to add up all the terms you get. So that's what summation means in general. And here we have our second formula, which is ai squared over bi. So when I say ai, I'm just going to be a subscript I. I'm just saying ai because it's shorter. So a subscript 2 squared over b subscript 2 plus a subscript 3 squared over b subscript 3 is greater than or equal to a subscript 1 plus a subscript 2 plus a subscript 3 squared over b subscript 1 plus b subscript 2 plus b subscript 3. And again, this will only hold true if a subscript 1 over b subscript 1 is equal to a subscript 2 over b subscript 2, which is equal to a subscript 3 over b subscript 3. So again, we have this inequality here, but it's only going to hold true if your different variables, they are in a constant proportion. So basically, let's just say my a1 is 2, my b1 is 3. So 2/3, these all need to be just, they have to be equivalent to 2/3. So they could be 4/6, right? That's fair game. But they have to be equivalent to 2/3. Then only this condition will hold true, this inequality that we have here. Okay, and finally, we have some more useful inequalities. So when both A and B are the same sign, so if they're both positive, they're both negative, it doesn't matter. They're just having the same sign, then A over B plus B over A is greater than or equal to 2. So again, if you have these two variables that are same sign, use this one. If you have A, B, and C and they're all positive, we are simply expanding it. So again, we're expanding this one to add in the C over A, and we're changing this to B over C, and we're changing it to 3 because we have 3 variables in here. But A over B plus B over C plus C over A is greater than or equal to 3. So just a simple change on this one. If you know this inequality, you know this one. It's not hard. And finally, if A is greater than 0, then you're going to have A plus 1 over A is greater than or equal to 2. So again, these are some simple inequalities. Don't be too hard pressed to memorize all these. You will eventually get to terms and you'll know how to use all these inequalities as you practice more with them. Okay, and then here are some more useful inequalities. So the following holds true when A, B, and C are real numbers, right? So A plus B plus C squared is less than or equal to 3 into A squared plus B squared. And here we have A squared plus B squared plus C squared is greater than or equal to AB plus BC plus CA. And finally, when A, B, and M are positive real numbers and A is less than B, we can use the following inequality. A plus M over B plus M is going to be less than or equal to A over B. So again, some more inequalities, and here are our final set of inequalities. So when all the variables are given here and they're all positive, you can do A plus B times 1 over A plus 1 over B is greater than 4, greater than or equal to 4. Here we have A plus B plus C, so we're simply expanding it, right? We're going to add on this 1 over C term, and this is going to become 3 squared. And again, we're going to expand it one more time, so we're going to add in a D. So we're going to add in a 1 over D here, and this is going to become 4 squared. So again, if you know the first one here, you can simply use the pattern to solve all the others. Okay, and here is our final sum problem. If x, y, and z are positive integers such that x squared plus y squared plus z squared is equal to 174, what is the greatest value of x plus y plus z? Mathcounts 1993 state. Also, one quick correction over here. It says a squared plus b squared plus b squared. This is a c squared. Because that should be pretty obvious, but it's a squared plus b squared plus c squared over here, because this is a plus b plus c whole squared. So that's why it's going to be a squared plus b squared plus c squared. Okay, so again, here's your problem. So I'll pause the video here and try to solve it if you can, and then play the video again when you're ready to go over the answer. Okay, so here you go. Using Cauchy's inequality, or you could have used the other inequality that we used over here. This one, a plus b plus c squared is less than or equal to 3 into a squared plus b squared plus c squared. Okay, so that's basically what they did here. X plus y plus z whole squared is less than or equal to 3 into x squared plus y squared plus z squared. And remember, they gave us x squared plus y squared plus z squared. So we already know one of the variables here, or we already know one of the sides of the inequality. So this is going to be 3 times 174, which is 522. So here's what we basically have now. X plus y plus z whole squared is going to be less than or equal to 522. Okay, so then it's pretty easy to square root both sides, right? So when you square root both sides, you're going to get x plus y plus z is less than or equal to the root of 522. And that's the same as saying x plus y plus z is less than or equal to about 22.8. So if you punch that into your calculator, you're going to get 22.8, around 22.8. I just rounded there because that's probably easiest. Okay, here's another important distinction we need to make. It says that x, y, and z are all positive integers. So if they're all positive integers, that means that when we add them up, they have to be an integer. It can't be a decimal value. So what that means is it can't be 22.8, it has to be 22, because that's the biggest integer value that's possible. And then there's also another method to do this. You could have just guessed and checked with different values. Obviously, I don't recommend this method. It works for some people, but what I would say is it's kind of like a time waster. It takes more time. Like, you don't have a lot of time on Mathcounts already. You don't want to waste time on one problem trying out every single possibility. So this is probably faster, but you could use it as check. So when I set x is equal to 5, y is equal to 7, and z is equal to 10, well, I'm able to find 22 as my maximum, so I know for sure that 22 is the right answer. So once again, I just use my inequality and then I checked it just in case. So again, sometimes you don't have time to check, that's fine. I just checked because I had time and I want to make sure my answer was right. Okay guys, thank you for watching. I really appreciate it. Please like and subscribe if you enjoyed the video, and leave a comment with any questions or email us if you have any questions about it. And yeah, just thanks for watching and have a nice day. See you guys.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!